Hey guys, welcome back to another edition of Mr. Monroe's Math. We're talking about using models to divide whole numbers and fractions, and we're talking about these two, particularly partitive division versus measurement division. Now what we see here, partitive, is we're using the part of some sort of a value. So in this case here, 15 divided by 3. The 3 is the part that we are going to be using. And with this part, we want to show exactly that, to be part of that answer. And so for partitive, we're showing in 3 forms, okay, the total of 15 divided into 3 groups, where we can find out that 15 divided by 3 is 5. So the value of each part is 5. Whereas in measurement, for measurement, what we're going to use is the answer itself. If 15 divided by 3 is 5, okay, we know that for a fact, we know our skills that well, that we can take this and divide it further and show that in 5 sections we know the value of each of those is the part, which is 3. So the measurement of all that is still going to be 15. So they're going to be equivalent with one another, okay? So partitive versus measurement. Partitive, use the part, use the divisor that's already given to you. And then for measurement, use the value of the answer, okay, to find and use the part in each of those measurements to get to 15. Both of these should be equal to 15. Okay, so taking that, let's make some models going forward of other values. Okay, so the next one's going to be this. We have
Bryson Pittenger, could you report to the office? Bryson Pittenger, could you report to the office? Thank you.
the joy of teaching. 9/10 divided by 3/10. So we have this value here, and we start. Yes, we always start with the model with the dividend, the first value here. Okay, this is where we start. Model this guy right here. So 9/10. So we have a model. And notice I draw 9 lines because there are 10 parts, 1 less line. Shade in 9 of them. I go to the last one. You can tell I've done this a couple times. 9/10. I'm showing 9/10. This whole value right here is equivalent to 9/10. I'm showing the 9, actually, that I should really show to this here. Before any of you guys catch me, I caught that one. All right, and then we're breaking up into groups of 3 out of 10. In unit form is the wording of this, and we say that it's 9/10. So notice we use a value, okay, and then the word form to get tenths, divided by 3/10. Now you can see they share the same unit form, okay, tenths and tenths. So we take the values, 9 and 3, and we can divide those. You all know 9 divided by 3. It's 3, okay, so we want to show 3 for each group, and that there are 3 groups of 3. So here is 3 out of the 10. This is out of the total value, all of these here, okay. This one here is another 3 out of 10. This one here is another 3 out of 10. Now there's 10 total, and I'm showing a total of 9 of them. So this added up together, 3/10 plus 3/10 plus 3/10 should equal 9/10, and they should line up to the same spot right here, and they do. So that last one right there is 10 out of 10. So that's just one example there. What if they're not easily divisible here? What if we change those values up? So last one for today. Love these erasers. All right, next one, last one. 8/9 divided by 3/9. Now you all know that 3 cannot evenly go into 8, okay? And again, we start with the dividend. The dividend is the value that you begin with, okay? 8 out of 9. So again, I'm shading quite a few here. So I have 9 boxes, I'm shading in 8 of them. So all but 1. So I work backwards. So I leave however many are left to make the whole, and shade backwards from right to left. my strategy, you can do yours differently. I'm showing 8 out of the 9. Okay? 8/9. And what am I dividing by? I'm dividing by 3/9. So for every 3 in the group. So that's 1. That's 2. And 3. And yes, I shade the next 3, even if there's one that's blank. This will give me my total answer here. I'll show you mathematically in a second. I have 1 whole group. I have 2 whole groups. And in this last one, there are 2 shaded out of the 3. This gives me a value of 2/3. And with a value of 2/3, that becomes part of our answer. 2 out of the last 3 almost make the whole amount. As we know, 8/9 almost makes the whole amount, but not quite. So our answer is 2 and 2/3. Okay? 2 and 2/3. So mathematically, how do we also do this? We take this value, we keep, change, and flip. One method to do it. Hello, sir. Let's erase this below. Eight ninths stays the same. Change division to multiplication. And I use the dot instead of the x as we get towards algebra. We do not want to mix those. All right? And we flip the second fraction. It's also called multiply its reciprocal. Okay? Multiply by the reciprocal. Now you want to remember that. That's going to come up a lot pretty soon. Reciprocal. Okay? Work on the spelling. We flip that second fraction. The reciprocal of it, of 3/9 is 9/3. And I can multiply across. I can also simplify here. Cross simplifying. You look at these 9s here. Okay? If I were to multiply all these values across, I would divide to simplify by 9. But I don't always have to do that. I can wait until later. So I know that 9 goes into 9 one time, and I can do that for both of them. Makes life easier. 8 times 1. Well, I got that. 1 times 3. How many times does 3 go into 8? Well, 2. So that's 3, 6. Takes 2 more to get to 8. And this denominator stays the same. So again, my answer is 2/3. So take these together, use that strategy. We'll spend more time on it, but make sure that you multiply by the reciprocal. You showed the modeling because that is what we are being tested on right now for this part. We have to prove why this form right here works the way it does, and we do that with those tape diagrams. Okay? So good luck. Smash the like down there in the bottom if you could. And as always, keep trying.